Good people, welcome to JG Tech Tutoring. Today we'll be focusing on inverse Laplace transform, right? Because now we did first principle of Laplace transform, and then we did the combination of Laplace transform, whereby we were trying to shift the Laplace transform function. Now we will be dealing with Laplace inverse. So that means it's an inverse Laplace transform. That means now we are now reversing the process, right? We are going to reverse the process. Now for the Laplace transforms, we just reverse the order, right? So now since we had something like this, and then we said actually it has to be integrated with these limits. Then for now we are going from this to this. We are going from this side to this side. Now we can just start with the basics one, because now we know very well that the Laplace transform of t is equals to 1 over s, right? So now that means now when we are dealing with inverse, we're gonna do this. So then the inverse of 1 over s is equals to t, right? Since this one is equals to this one, now they will give you this looking for this t, right? So now if they say the inverse Laplace transform of 1s minus 2, so that means now this one is a the Laplace of combination, the Laplace of shifting, right? This is the Laplace of shifting, right? So now that means here we just have to say this is equal to this, right? That's all, right? That means it's equals to 1e to the power 2t, right? Because if ever they give you 1, the Laplace of 1 is 1 over s, right? So if now they give you 1 e2, the Laplace of this, it will be 1 over s minus 2, right? So now that means the inverse of this is equals to e to t, right? So that's what we need to do, right? And then in the inverse Laplace, there are many things that you need to be able to manipulate, So now if you are given something like this, s over s squared plus 16, then what is the inverse of this? First thing first, we have to know that this is equals to, this is actually in a form of something like this, right? And then this is equals to what? Cos AT, right? So now if we can bring this into a form of this, we'll have what? 4 to the power 2, right? So when we have 4 to the power 2, now we know that this 4 is acting as a, so that means it will be cos 4t, right? So this is the inverse. Now let me just do another example. Minus 9, right? Minus 9. So that means this one is going to be what? Sec 3t. That means this one, it's actually this, because this one, its rule says s, and rule says a divided by s squared minus a squared, right? So now a squared is 3 squared, right? Then 3 squared is equals to 9. 3 squared is equals to 9. So now I think by now you have already mastered this inverse. You just have to do many practice. Now let us go to the combination. Let's go to the combination of inverse, right? Because there are those questions that you can see that you have to use the combination rule. You have to use the combination rule, having given something like 2, or just e to the power negative t sine 2t. If you are given this with the straight Laplace, it's going to be 2 over s squared, right? S squared plus 2 squared. So that means, as I told you to the previous one, first thing first, we focus on this. Then after getting this answer, we now say we are including s minus 2, right? So now that means it will be 2 over s plus 2 squared plus 4. That's how it should be. But now that means if now we are given something like inverse Laplace of 2 over s plus 2 squared plus 4. Now this inverse, that means now we have to start knowing that, okay, because it's having a numerical number in the numerator, so that means numerator is numerically, that means now this is sine, and then here it's positive, that means it's sine, not hyperbolic sine. So now that means we have to write sine down. First thing first, sine down. Now because here it's 2, here it's 4, that means here is 2 to the power 2, here is 2, so that means now our a is 2, then t, right? So now another thing, now that here it's positive, that means this thing shifted, but then here it's positive, that means it has to be e to the power negative this 2t, right? So that means this is the correct answer when we are from this side, when we are actually from that side. Now I can do as many examples as I can to actually get you a very good style of solving problems. Now here we're given this, here we're given this. They're saying we should take it back. First thing first, we have to check the shift, right? Okay, not checking the shift, we can check what is it that is this. So that means this one is what? It's sine, right? It's sine, but then we are now not sure about what's going on here, because it was supposed to be 4 here, and then here it should be 2 when we're dealing with sine. Now let's now try to put this in order. Now we have to now say, okay, I'm not going to solve anything now. I'm not going to solve anything now because you are being unfair. Laplace transform, you are being unfair with me. Now I need to try by all means to be manipulative, right? So now we are going to take this 3 here and then divide it by 2. Why are we dividing it by 2? Because Laplace transform, it's saying there should be 2 here for this thing to make sense with sine. There should be 2 here for these things to make sense. All right. There should be 2 here for these things to make sense. Right. Now that there is 2 here and there is 2 here, that means here it's 1. This is 1 because there is nothing here, because this 2 is just here, and imaginary 2 because there is 2 here. So if ever we have to multiply this to take this back, they're going to cancel out this, right? They're going to cancel out this. Now that we just have 3 over 2, now whatever that is in the inside the Laplace transform, it is now meeting the requirements of sine. So now we're going to say et, we're going to say et sine 2t, right? Then multiply by 3 over 2. So this is the only correct answer. This is the only correct answer. This is the only correct answer now. So guys, we have many questions that we can do. For now, like, share and subscribe. Then I'm gonna come up with a very interesting topic in engineering mathematics, whereby we will be doing the functions, step-in functions, and also do Fourier series. So like, share and comment, right?